Welcome to Amsterdam and KubeCon CloudNativeCon 2023. Join John Furrier, Savannah Peterson, Rob Strechay, and UPSCOT as theCUBE covers the largest conference on Kubernetes, cloud native, and open source technologies together with developers, engineers, and IT leaders from around the globe. Live coverage of KubeCon CloudNativeCon 2023 is made possible by the support of Red Hat, the CNCF, and its ecosystem partners.
Hello and welcome back to theCUBE's live coverage here at KubeCon CloudNativeCon Europe. I'm John Furrier, it's Savannah Peterson, host of theCUBE. Savannah, we got a great new format here, a panel
Excited
concept.
for it, John.
Kelsey Hightower was supposed to be here, got lost, he's getting jumped by his fans, but two great guests, Matt Butcher, Fermyon, and Justin Cormack, Docker, both CTO and CEO respectively, to unpack WebAssembly, also known as WASM, and get the view on AI. Because this is what we've been trying to get a hold of.
I'm excited for this one, this is hot, everyone's talking about it. Let's dig in.
Matt, welcome back. Last year you launched at KubeCon Detroit.
Yep.
Welcome back to theCUBE.
Yeah, thanks, I'm happy to be here again.
Justin,
Yes,
you've been on theCUBE
love
multiple
it.
times with DockerCon 2021, 22.
Yeah.
Things are good, and I know business is great for Docker, so congratulations. You guys are rolling with WebAssembly, congratulations.
Thank you.
It's a hot topic.
Oh yeah.
It is, yeah, especially here at KubeCon.
Yeah.
Oh yeah, baby.
Binaries, assembly, I mean that's the language of love for developers. Right?
That's right.
It's getting steamy in the afternoon on the cube today, here we
It's
go.
a sexy topic.
We're talking martinis, we're talking, anyway.
So let's unpack it. Let's get on the record on the video. What is the purpose of WebAssembly, WASM? What is it? What's it do? Why does it exist? What's the North Star? Let's lay that out there so people can actually get a good video definition of the concept.
I think the good place to start is what it was originally built for. As we know, as web developers and now cloud developers, JavaScript was the language of the browser. And over time, over the browser's history, we started trying to use other languages like Java, like ActiveX,
and compiling things to JavaScript as a way around not having other languages.
Right.
So things like Gmail was compiled from Java.
And none of them really kind of had the staying power, plus a lot of the things we really valued about these other programming languages didn't quite carry over in that, in that set of circumstances. So WebAssembly was invented to kind of attempt to rethink what it would be like to have multiple languages that could serve inside sort of an assistive role, I think I'd call it, right? With JavaScript in the browser. And the idea was you could take a bunch of off-the-shelf languages like C, the one language that has deep pedigree, and Rust, a language that at the time had been around for a couple of months, I think, when WebAssembly was started in 2015. And the remarkable thing about it was that the core team who started working on WebAssembly, they said, we want to do this in the open. We want to do open source reference implementations. We want to have all the browsers supported, and we want to standardize it all up front, because then the industry will just agree this is the way it ought to work.
And it's not a compiler.
No, it's a specification for the instructions on how to run the code, but it's compiled generally by the normal language compiler nowadays. So like if you have used Go just has WebAssembly as a target. You use Rust, it has WebAssembly as a target, so it's built into your normal compiler, and it's just another thing you can output instead of native code.
And what's the benefit for the developer? What's the value to the developer?
I mean, this initial value proposition was that you could take
existing code,
Yeah.
like you had some code to do some image processing, you could just run it in the browser without having to rewrite it in JavaScript, which would be a huge pain because this is like code that you developed over decades.
Yeah, we're trying to get rid of wastage in all of the software development, and this was a way to do it. And I think also there were some use cases where writing in a low-level language like Rust or C++ and then compiling it to WebAssembly would help with some of those kind of number crunching types of operations.
Yeah.
That's where Figma and Adobe really found a lot of use cases.
So bottom line is, it was a pain in the ass for developers to rewrite code. Okay, that's why the mass adoption on the compiler side was rampant. Easy, makes things easier to integrate and run code. So
and
what took so long?
Right, that's good.
Well, there was a lot of full starts and kind of attempts to do it. There was ASM.js, so it was an iterative process, not just like this is the best idea ever, let's just do it. It was like, we tried this, we can still do better. You know, it's that kind of...
It's a good idea, it's hard, let's do it right.
Yeah,
kind of thing.
And I think there were 3 characteristics of WebAssembly that proved to have value outside of the web browser, where in its sort of initial environment, and we're starting to see it sort of spread out into different ways. And those 3, maybe you have a different list. The 3 for me are, it has a great security model, which is always one of the things we want to make sure we do well, and oftentimes it's one of the last things we think about. This time it should be one of the first things we think about.
Yes.
The second one is its performance is just off the charts. You know, we want fast execution environments because you know, when you look at a website and you first load that website, you want it to load right away. Well, as you can see, you know, in the cloud world, we're really struggling with those same things. How do we keep speeding things up, and how do we get the most out of it? So I think that's the second one. And the third one was this kind of neutrality. Typically, when I compile a C program, I compile it to a specific operating system and a particular architecture. And that means if I build it on, you know, a Mac on, you know, the latest, greatest M1, M2 processor, you can't run it on your Windows box. You have to, somebody has to recompile it and run it there. WebAssembly provided a binary format that could run on all these different devices, really from, you know, very specialized small IoT devices up to, you know, the big server grade hardware that we see in the cloud and elsewhere.
Yeah, I mean, it's the right ones run everywhere thing that with the Java promised, and it worked to some extent with Java, but not everywhere. Like you know, Java in the browser was a thing for a little bit and then went away again because it didn't have the right security models. Like, I mean, you got the first one, the security model, it has to be the right security model for all these different environments, and that's hard. And we learned a lot, you know, again, over the decades of working out what the security model had to look like, and that's, you know, why the WebAssembly security model is different and stronger than the previous
just to
ones.
follow up on that real quick, I know Savannah wants to jump in, but the extensibility question might come up, so I might say, okay, that's great, but what about the security model if it changes? What makes it extensible? Is it standards? What's behind the extensibility?
Well, I think part of it is that WebAssembly on its own doesn't specify the external interfaces to the outside world. It just has a model where you define those when you create the application, you know, the runtime in the application, and I think that's always been the browser model. Like to build the browser security model, you have, you know, things you plug in, like, you know, new standards that each time you add something, you make sure that you understand the security model of the new thing you're plugging in, and it's hardened. You know, so WebGPU came out recently. It's like adding a GPU security model is difficult, so it's taken a long time, and it's like hard work, but it's like you build these interfaces and the libraries to implement that, and then you validate the system as a whole with that API and make sure you understand its full behavior. And it doesn't have a sort of generic extensible thing. It doesn't have a really big standard library like Java did. Java, you know, had a lot of security issues in the standard library, and that was part of the weakness of the Java security model. The standard library was big. WebAssembly is quite small, the spec's small and easy to understand for the runtime.
And I think, I mean, to flip the question on its head, right? If WebAssembly is sort of like a nice closed little system, and it's really up to the people who use it to say, okay, we're going to allow it to do this little thing now, right? We're going to allow it to go reach out to the internet and grab a resource and pull it in locally. We're going to allow it to read these 4 files on the file system, but nothing else. And so that kind of inverted security model, the capabilities-based security model, where the control of what it's allowed to do is external to the language itself, means that when we start with it, it's very secure. And then as long as we follow the rules and we're wise and diligent in the way that we build the system, you just open it just a little bit and allow a couple things through. It's like a little clam, it's very cute. But
and a lot of testing and a lot of testing. And
sometimes it's got a pearl in it.
I was going to make a pearl joke. Beat me to it, Matt. You beat me to it. I love it. Well, so let's dig in there a little bit. And Justin, we were talking about this in our virtual green room here just before. Where are we at with WASM now? What's the lay of the land? I mean, John was joking what took us so long, but we're still pretty early.
It is early. I mean, it's you know, it's been a few years. I think that we've actually, if you look at what we've done in the last few years, you can see we've come a long way. I think the biggest thing, I mean, you did a blog post about it at the beginning of this year about almost every language now supports WASM, or is about to support WASM as a compilation target, and that was really difficult before. It was like, well, you can use WASM as long as you write all your programs in Rust or C.
Right.
And it was like, anything else, you're out of luck. And
it's sort of the old Model T thing. You can have a Ford in any color you want as long as it's black.
Exactly.
But we're past that. So now, like the compilation target side of things is settling down. There's still work to do. And there's new features in WebAssembly to support new things like being added and things like that slowly. But the basic thing of like, I can write a program, I can find a compiler for it, and I can compile it to WebAssembly works, which is like really what you need to enable the developer to get started.
Yeah.
So that really feels like it's got somewhere over the last few years.
And I think part of the newness, part of the reason it feels new, is the same reason we kind of saw Java feel new when it was really a few years old, and Ruby feel new when it was 10 years old. You need these kind of technologies, we write them for specific cases, and sometimes we're right, and we do a great job on it, and other times we're just totally wrong. And Java was originally written to run in very small devices. It was an embedded language. That's probably its least utilized use case at this point.
That's definitely not what I associated with it. Oh, no,
it found its niche outside, and Ruby was
it found multiple niches as well, because it's Android was one of them, and the enterprise was another, which are just very different as well.
Yeah, and Ruby was kind of the same. It was a scripting language to orchestrate Unixy things, and then Rails came along, Ruby on Rails came along, and suddenly every web developer, and Chef,
I mean, totally
suddenly
different.
Every developer that was doing anything on the web or doing anything in sort of orchestration had to know these languages. And I think that's what's going on with WebAssembly, is it started out trying to tackle a problem that it has found some traction in. There are a number of popular websites, like we talked about Figma and Adobe, that use it. Yeah. But now, and this is where Justin and I get really interested in it, we're starting to see applications of this technology elsewhere, where we kind of lift out the WebAssembly runtime from the browser and plop it in Docker, and can execute WebAssembly there, and we plop it in Fermyon, and we execute WebAssembly there.
Or you plop it in Nginx or Istio and like other places like...
Or databases.
Well, this is where I think it's compelling. This is where we'll get to the AI thing later, but this is where, you mentioned browser, but browser is a browser. It's not a mobile app. There's mobile browsers, and you got AI apps coming. The application frameworks are growing significantly. Open source is growing. So there's now new capabilities.
Yeah.
What are they? What's the sweet spots? What do you guys see the value? What do you see as areas that are going to be opportunities for WASM to grow with developers? That's not just in browser specific.
I've kind of got my 4, and you've probably got a different set. I mean, browser is the obvious one.
Yep.
We talked about that already. I think IoT is another one where you're dealing with
mobile
very
browser
small...
too?
WASM is supported in all browsers, mobile and desktop. That was part of the importance of it being a universal platform and supporting that. So
probably every device on this table already has WASM support in it. That's kind of how quickly it's moved out there under the radar. And I think IoT will be a big application. I think we kind of jokingly call it the last plug-in model you'll ever need, because it is a great technology to plug into existing systems and allow developers to extend them.
And plugins is an area that people don't think about much, because it's a kind of weird thing. It doesn't really have a very big ecosystem, but it is really important. And
why is it important?
It's the basis of there's always, when you're trying to build a platform, you need an extensibility model for like, how do I do new things that the platform hasn't thought of for me?
Yeah.
And that's usually some form of embedded programming, embedded scripting, all sorts of, Salesforce, for example. Yeah. It's a big scripting platform, basically. It's like these things are huge, and
platform,
you just ignore
maybe
them.
tool.
I
don't want to go there.
I was going to say, are we really going down that?
No.
That's a good
Stop.
idea. I'm just going to redirect. I'm like a bumper over here.
Sorry,
I'm just going to keep us in the lane.
Kind of came out,
which is rare for me.
But under is there a middle layer kind of underneath the apps, the browser? You mentioned containers is a hot area. So where does it fit into all this growth here as people start moving off, say, virtual machines, bare metal apps to cloud native?
Yeah, and that's where I'm most excited about it, is I think with WebAssembly, the kind of 4th use case, and the one that Fermyon is most passionate about, I think the same one that Docker is most passionate about, is that we can use the WebAssembly runtime as a lightweight, very portable execution environment that complements the existing virtual machine and container ecosystem. But because it's got that strong security model and ultra-fast startup time and cross-language, cross-platform, cross-architecture story with it, it means we can build some of the things that have really been sort of a struggle for us to build in the past, do really well in the past.
Like what?
An example of that is serverless. I mean, when we think about serverless, a couple years ago it was all the hype, but it didn't quite live up to the hype. We didn't figure out how to solve some of the difficult problems. So it started to kind of downtrend a little bit, and then we looked at it and we said, well, okay, some of the problems we were seeing is there's a mismatch between the architecture underneath and the kinds of applications we're trying to write. WebAssembly is a better architecture to sit underneath that and be able to start things just with supersonic speed and just execute them very quickly.
If you kind of look on Stack Overflow about the kinds of problems people have with serverless platforms, a lot of it's about cold start time, keeping my app warm, all this kind of...
And vendor lock-in too.
That as well, yeah. But I think that people are spending time managing things about the platform rather than things about their application. They want to just write their application and have it magically work, and it's not quite there.
Right, yeah.
This has been one of the side effects of successful DevOps. It starts operating, then you got to start managing that op a little bit. And this is where potential AI comes in or other things. So how do you guys see that nurturing of the infrastructure? I mean, basically you got to nurture your app.
Right.
I mean, take care of your app by not paying attention to the things that you just need to run.
Yeah.
That's what you're basically saying.
I mean, I mean, there's a big overhead with applications about running it and the infrastructure you need and the code you need and the configuration you need, and it's been liberating that we've had these platforms that we can do this and we can build cloud native things, but there's a lot of complexity, there's a lot of time and a lot of effort that people are having to deal with these.
All right, bottom line as we wrap up the WASM portion, what is the outcome going to look like for developers? Go shoot the arrow forward 5 years. In your mind's eye, if you had the pixie dust, the magic wand, what would you hope to have happen? We'll start with, go ahead. I'll start with you.
Fake left, yeah. No, for me, I think what we are most excited about is I think that this is going to redefine some of the layers of the cloud. It's going to allow us to build the kind of serverless functions we've wanted to build for a long time and the serverless apps we've wanted to build for a long time. But it's going to do it in a way where, first of all, I hit on vendor lock-in just for a second there. That's one thing we want to avoid. We also want integration with Kubernetes, with Docker, with virtual machines. And so I think what we're going to see is a move toward a simpler developer model in this serverless functions way, and a move that also complements sort of the operational model that has become popular now. Right, so the way I kind of think about it is the pendulum swung many years ago very hard in the developer side, and we had Heroku and things like that, swung all the way over to the operations side where the developer was suddenly like, I don't understand any of this, but the operator really liked it. Now we're trying to sort of reset it in the middle where we can say the developer concerns are here, WebAssembly does this nice job of wrapping all of that right up, and the operator still has all the flexibility on their side to build the kind of applications they love building with tooling like Kubernetes, or even if we rewind back, Puppet and Chef and tooling like that.
So simpler tool base, easier to code.
Yeah, it makes the developer story much easier, but still gives the platform engineer the kind of control that they really want and need. Yeah. Everybody's happy.
Everybody's happy, love that for our future.
I think that enabling developers to just write applications that can really run in all sorts of places and use the same code in a lot of places, and recuts of your app depending on whether you want to run it, parts of it in the cloud, parts of it in the browser, parts of it on serverless, like this gives you the flexibility to structure your app. I think we're seeing, with microservices, we're seeing that it's a very different kind of operating model than it used to be with monoliths, where your app would run and sit on a mainframe or in a big data center. Yeah. Now parts of your app are running on the edge, parts of it are running in the browser, parts of it are running in microservices. Like, you've got this flexibility to put things where they need to be, recut them, move them around for performance reasons, for latency reasons, for ease of development and shipping reasons, for ease of update. Like all these All these things give you these options, but if you have to have a different technology for all these different things, it's really
It's a cluster,
bad.
and not, no pun intended. Yeah. Or maybe intended.
Well done there, well done.
Well, and the market is ready. There's a tailwind for cloud native, so much more growth. Look at just the migration from old tech to kind of cloud native. It's still a lot to go on.
Oh yeah, and I mean, it always comes down to the same things. We want to do more faster and with less complexity with high security.
Yep.
Yeah.
And it seems like
And
that's where
cheaper,
we're driving.
also cheaper.
I mean, obviously, and cost optimized as well as everything else. But it's about that accessibility. I mean, Docker's been a platform that's been making a lot accessible for people forever. And forever, at least for my forever, as far as my mind is concerned when it comes to the internet. And I love it. Is there anything you guys disagree on?
I mean,
Tea and coffee, I think.
That's tea and coffee. Yeah, but I think there's still
Team coffee.
it's still new WASM. It's like, and there's still a lot of different directions it could go in. There's different things that could be important. I think that we haven't seen yet the thing that makes a million developers say, I must use WASM tomorrow. And that's the thing that we're still kind of feeling our way around.
Except this interview, maybe this interview will be that.
Well, the compiler targets is a big table stakes. That's critical.
Oh, absolutely,
Number one
100%.
baseline.
Yeah,
That's a major achievement.
And and that's why I feel that this, last year was kind of the first year that WASM could start to succeed.
Right,
because
run
before that it
anywhere
was
is
just, we looked at it, 5 years ago, I think when Solomon's tweet was there, that was when we were experimenting with stuff, and it was like, this stuff's early. Like you're going to spend all your time building the tools to make it possible, and not working out what the amazing bit is. And now it's different.
Well,
we track all the top 20 languages and their progress toward WASM. And at this point, 17 of the top 20 have WASM done or significantly in flight. So I think, to your point, from 3 years ago to now, we've seen the tipping point.
Yeah, you're going to need that next Figma to say, okay, I could do that fast. And I get it. Yeah. I think it's going to, the bit will flip. And then I think the tsunami of the migration of developers to it. Once they see that everything's tightened up.
In my optimistic take, it's flipping now. What do you think? Yeah. Now, year, 2 years?
Fermyon would say
last week?
It's flipped right now in theCUBE, right now.
Yeah, right now. There we go.
This was the moment. But no, I think there's definitely, the trajectory is up and to the right. The amount of interest at KubeCon, like in Detroit and here, is just this is
super
where
exciting.
It's one of those moments where it's about time, it's here, it's real, it's getting real every day. Compilers are there, targets are there. Reusing code, then the flywheel kicks in.
Yeah, exactly.
Guys, this is a masterclass.
I know, this is great.
WebAssembly WASM.
I learned as much as I cracked jokes.
Thanks so much for unpacking that. We'll be back with another panel on AI right after this. We're going to unpack it all. Stay with us, theCUBE. I'm John Furrier with Savannah. We'll be right back.